Alright guys, we're back. We are going to go over some examples. I do still have an audience here, so hopefully it'll be a little bit more interesting than if it was just me alone. Alright, we're going to sketch a triangle that's similar to the triangle below using a scale factor. We just talked about scale factor in the last little miniature video about how much bigger something is or how many times smaller something else is. Here we have a scale factor of 2, so I will ask my audience here, will my picture be bigger or smaller?
Small. Bigger.
It will be bigger. You're so smart because they're saying that for everyone here, you're putting 2 units on a bigger shape over here. And the other hint was that it's greater than 1, and we said anything greater than 1 will give you a bigger picture. So for every one little unit, I'm putting 2 right here. For every one here, I'm putting 2, so that's why the picture's going to get bigger. Now the cool part is to come up with your new measurements, all you do is multiply. So 5 times 2, what do I put here, guys? 10. And 2 times 2, alright, and the bottom one, 4 times 2 is 8. And there you go, you just went ahead and drew a similar object from left to right. Now I'm going to have to stop. We got company. No, I can't stop. I got to keep on going. I'll catch up with y'all later. Okay. Alright, I'm sorry, we're still in the video, we're recording. Okay, we're going to keep on going here. So, times 2. You just did your bigger shape, and my audience will answer. Was that enlargement or reduction?
That was enlargement.
Very good. It was enlargement, got bigger. Next one, we got triangle EFG, which is dilated, meaning bigger or smaller, to triangle EFG prime. That little mark right there means prime tells you that it is a copy of the original shape. So we're going this way. Just looking at it, is that going to be enlargement or reduction? Enlargement, because it got a little bit bigger. The reason you know, here's a 6, this one turned into a 7.5. Alright, so it is an enlargement. You can write that down real quick. It says, what is the scale factor used to dilate triangle EFG to form triangle E prime, F prime, G prime? Alright, what were my labels for scale factor? Anybody? Large over small. Alright, if you forgot that, you have it on your notes, you'll be fine. Here's my large shape, and here's my small shape. See you later. I have company from the high school. How's it going over there? Pretty good?
Yeah. I want to be back here, but
Aww,
I missed your class the most.
you can come and help tutor on Thursdays. Don't forget.
Next Thursday.
Got it?
Hey.
See y'all later.
How you doing?
Alright, we're back. Sorry, guys. Here's the large. Choose something on the large, 7.5. And then on the small shape that's in the same location corresponding is going to be the 6. Everybody okay there? We could go and change it up, but honestly we could also leave it like that. It's no big deal. You could divide it out. Why don't we divide it out? Because this means divide. 7.5 divided by 6. Bring up my decimal. How many 6s can I get out of 7? 1. And I got a 15. How many 6s can I get out of 15? 2. And that is 12, and I have 3. I'm going to take my 3. Well, no, let's keep on going. I was going to put a fraction. How many 6s can I get out of 30? 5. So I can actually say my scale factor is 1.25. That's my scale factor right there. And as you notice, it is greater than 1, which makes sense that it got bigger. Got it? All right, let's keep on rocking and rolling. Next part says triangle EFG is dilated to form EFG prime using a scale factor of 0.25. Right away, what comes to mind when we see scale factor of 0.25? What kind of picture? Reduced. It's going to be a reduction because it is less than 1. So let's go see our questions. Write T before the true statements and F before the false statements. The dilation is a reduction. That is what? True, because that is less than 1. We just said that. The perimeter of triangle EFG will be larger than the perimeter of EFG prime. Will it? It's going to be false because we have a picture of a triangle that's going to be a smaller one. So the perimeter around will actually be smaller. So that is false. And the next one says the two triangles are congruent. What does congruent mean? The same. Are they going to be the same size? False, because they're going to be different sizes, same shape but different size. All right, rocking and rolling. Let's keep on going. Let's finish this up. It's a sketch over here, a rectangle that's similar to the rectangle below. Use a scale factor of 0.5. Okay, bigger or smaller? Reduction. All right, so I know I'm going to draw a smaller one here. I'm going to put here times 0.5. I could actually put times 1/2 also. It works in a fraction. And label the sides. Okay, here we go. 5.5. What do I got to do to get my new one? Multiply it times 0.5. Let's go do that real quick. 5 times 5 is 25. 5 times 5 is 25. Plus 2 is 27. Multiply. You got to count those decimal places. 1, 2. And I've gotten 2.75. Is that what y'all got? All right. Now we got to do this side. 2.5 times what? 5.5. That's 25. That's 10, 12. Count over 1, 2, 1, 2. And it is 1.25. You just finished that problem. I'm getting messy here. Sorry. It's late and we're hurrying. I guess we will, well, no, we'll jump down to the very last section. I don't want to run this video too long and we're already at 5 minutes. So just real quick, let's wrap this bottom part up. What type of dilation would result from the following scale factors? 0.25.
Reduction.
Reduction. 1/8.
Enlargement.
What do y'all think, guys? Is it less than 1?
No. Yes.
Yes, it is. It's 1 part out of the 8. So that is going to be a reduction. 3/2 is an enlargement because it's an improper fraction that actually mixes out to a mixed number 1.5. So that is an enlargement. How about 1.55?
Enlargement.
Enlargement because it is greater than 1. And 0.99? Reduction because it is less than 1. And 1.01? Enlargement. All right, guys, we're going to have to say goodbye fairly quickly because we are at 6 minutes, almost 7 minutes, and I hate to bore you with our craziness. But I think everybody wants to say hi again to whoever else they're going to shout out to. Go for it.
Second period.
Second period. 7th period. Anybody else have a shout out? Come on, Kevin, who you want to shout out to?
Unicorns.
You just revealed our
Whoops,
number.
the other Kevin I meant from the other class. Okay, talk to you later. Come back, I'll show you some more examples.
Unicorns out.
Bye.